welcome you to the next session in the module 4, that is rule-based classification classifiers. So building rule-based classifiers. So how are we going to build it? So here building is nothing but, when I say building rule-based classifier, it is nothing but extraction of rules or the rule set, extraction of rules or rule set. So what we have to do here is this rule set or the rules, it identifies the relationship between the attributes and the class label. So it identifies some kind of relationship. Each rule identifies the relationship between the attribute values and the class label. That is what it is, right? The antecedent part and the consequent part, what I'm telling here is. So to extract the rules, we have two ways in which we can do. One is direct method and the other one is indirect method. When I say direct method, I have a training set given to me. From the training set, I'm going to derive the rules directly. In case of indirect method, what I'll do is I'll make use of other classification techniques that we have, and then we derive the rules. Say, for example, take the decision tree technique. For the given training set, I will construct a decision tree. From the decision tree, I will derive the rules. So that is indirect method. Direct method is deriving the rules from the training set directly is direct method. In indirect method, first I will derive a decision tree, and then from the decision tree, I will derive the rules. So that is indirect way. Okay. So we'll first see what is the direct method or what is the technique that we are having with respect to the direct method of extracting the rule set or extracting the rules. Okay. So here from the training set given, we are going to extract the rules directly. For this, we are going to make use of sequential covering algorithm. Now, what is this sequential covering algorithm? So how are we going to extract rule using this particular sequence covering algorithm? So here, with respect to sequential covering algorithm, the rules are grown in the greedy fashion, and the growth depends upon a certain evaluation criteria or the evaluation measures. We will see what are those. If the training set has more than one class, then growing the rule will be in such a way that we will consider class by class. So first we'll consider one class and derive rules, all possible rules for that particular class. Then we'll consider the second class, we'll derive all possible rules for that class, and it goes on. Okay, so this is what do you mean by actually a greedy fashion is. Now, what the working of sequential algorithm. So what here, there is one challenge. When I say this, you will consider one class at a time. The question that now arises here is which class you will consider when you have more classes. How are you going to consider that which, the previous rule set, I had 5 classes, that is birds, amphibians, reptiles, mammals, okay, so other 5 classes or 6 classes we had, correct? Now, why did I consider birds first there? Because using the class, vote of the class as a measure, correct? Similarly, similar to that way here, we will consider any one measure and take consider a particular class in the first way, and then we are going to consider the next class, and then we are going to consider the third class, and it goes so on. So let's see how the sequential covering algorithm works, or what is the sequential covering algorithm is. Okay, so this sequential covering algorithm starts with an empty decision list. So here decision list means what? I've told you which rule set is called as decision list. Ordered rule set, correct? Ordered rule set is called as decision list. So I'm going to consider, which means the rule set that I'm going to extract here will be an ordered rule set. So that is indirect way of referring it. Okay. So now I'll begin with the empty rule set, correct? Empty rule set. Then I should have class labels. No, I will have class labels listed in some order. I would calculate, say, consider vote only. Say, consider vote only, frequency only. Based on the frequency, I have listed my classes that is present. So okay, I am starting with the empty rule set. Also, I'm starting with the ordered class set because I need to know which class I have to consider first, and then which second, which class I have to consider. In third case, which class I have to consider. So I will have an ordered class set also. Then I'm going to apply learn one rule function. So until the stopping condition is met, I will be applying this learn one rule method, which help us to extract the best possible rule. Okay, so this is how your sequential covering algorithm works. First, we'll start with the empty decision list. Then you also will have an ordered class list. You are going to apply a learn one rule. What is this learn one rule? I will tell. So you are going to start with, you are going to apply this learn one rule repeatedly until the stopping condition is met. What is stopping condition? It depends, and that also I'll let you know when I take the example. And then once this is done, the new rule or the new rules, as and when I'll be deriving it, I'll be putting it to the bottom of the list. So first rule and then the next rule is added next, because I have to derive it in the as a decision list, right? That is the ordered rules. So new rules are added to the bottom of the list. Once the stopping condition is met, when I come out of this learn one rule function, at the end, what I'll do is, in order to have that exhaustiveness, I will be adding a default rule also. I'll be adding a default rule also. So this is how the sequential covering algorithm works. We'll start with empty decision list. We will also have an ordered class set. So that which class to be considered first and then next and so on we can easily identify from this. So how am I going to do this? We can use various measure. Frequency will be the best one. So which class is frequently repeated, I'll put it in the first or higher in the order. That's all. So that becomes my ordered class set. And then our actual algorithm or the function lies here, that is learn one rule. So how is this done? We'll see. Until a particular stopping condition is met, this rule keeps on repeating itself. Okay, so as and when I derive a rule, I'll be putting it into the rule set. So I'll be putting it to the bottom of the rule set. What do you mean by bottom of the rule set? One rule is derived, the next rule comes, I'll not put above this, I'll put below this. So the third rule will be put after second rule. It will not be put before first rule, right? So that is why it is said to be as a decision list. Order is maintained. So once all the rules is derived or the stopping condition is met, what we have to do is finally add a default rule. So you know what is the use of this default rule? To maintain exhaustiveness of the rule set, we have to use the default rule, correct? So this is your working of sequential algorithm in brief. Okay. So now we'll see. I'll take this is in simple words I've told how the algorithm works. This is actual algorithm. You can take the snapshot of this and write it in your notebook. Okay, so here, as I told, you can see here the training records will be there and attribute value space. So this first thing, you will have the training set. That's all. So you have an ordered rule set. Also, you have the initial rule set. That is empty rule you are having. So here for each class, that class is here. Based on this class, for each class, what I'm going to do, until the stopping condition is not met, I'm going to apply the learn one rule function, and I'll be adding the rule to the bottom of the list. So once the stopping condition is met, I'll come out of everything and then I'll insert the default rule. So this is the sequential covering algorithm. Okay, so you can take the snapshot of this and write it in the notebook. Very important. They can ask you to write the sequential covering algorithm and explain in examination. Very important question. Okay. So now, what is this learn one rule function? So how is that this one learn one rule function is going to work? So we'll see that. Okay, so all the records belonging to the particular class is considered as a positive example. So this is the first thing that the learn one rule function does. You have records and which belongs within the training set. I'm talking about the training set here. In the training set, if you now imagine the training set that I had given, the big table which I had given in the last class. So in that training set, we have records belonging to various classes, correct? So when you consider one class, say consider you have considered birds as a class for which you have to derive the rule. So now what you will do is you will consider that bird record that belongs to bird as positive example, and all other records will be considered as negative example. Hope you have understood what is this positive example and negative example and how are you going to consider it. So positive examples are that records which belongs to the class that we have considered. So as an example, what I told, say consider let birds be the class for which I have to derive the rules. Let birds be the class for which I have to derive the rules. All those records which belongs to birds in training set will be considered as positive example, and all other records which belongs to various other classes will be considered as negative example. Understood, right? These two. So it is very important to understand this learn one rule. Okay, so here you are going to consider the record belonging to that particular class to be as a positive example and all other records is as a negative example. Now, so desired rule is extracted. Once you have considered the positive example, you will derive the rule for that. Now, what do you mean by the desired rule here? You have to understand this. Why I have written is written here as a desired rule. The desired rule is the one which covers maximum of positive example and minimum of negative example. So when I write a rule, it doesn't mean that the rule that I've written should always cover a given class only. There might be a chance that it is not covering the particular record. Okay, so that is what it is. That is what I meant here. Desired rule is that rule which has capability to cover maximum of the positive examples than negative examples. I can tell that no negative example will be covered or very few negative example will be covered. So that is what is a desired rule. And when as and when we derive a rule, we are going to add it to the bottom of the list. Okay, next, eliminate the records covered by the rule. Eliminate the records covered by the rule. So once you derive one rule, what you have to do is you have to eliminate that particular records. Which why we have to eliminate, all that we'll see next. Okay, so this is how the learn one rule function works. Learn one rule function works. So desired rule is extracted and it is added to the bottom of the rule set. I am going to eliminate the records covered by that rule because I have derived one rule now. So whichever record is covering is triggering, or whichever record is being covered by the rule, I am going to eliminate all those records. Okay, and then I'll continue to derive the next possible desirable rule, and I'll continue this until I don't find a desirable rule. So after that, what I'm going to consider is, and I'm going to take the next class and I'm going to repeat the same thing. I'm going to take the next class, I'm going to repeat the same thing. So this is how your learn one rule function works. So what do we have in learn one rule function? First, we will consider all the records that belongs to a particular class as a positive example. All other records will be considered as negative example. So I'm going to extract the desired rule. What is this desired rule? That rule which covers maximum of positive class and minimum negative class or no negative class. That is what is desired rule. So once the rule is identified, I'm going to eliminate the records covered by that rule. Once the rule is identified, I'm going to eliminate the records covered by that particular rule. And I'm going to continue this until I don't find a desirable rule for that particular class. I'm going to continue this, that is finding the desirable rule, eliminating the record. Find a desirable rule, eliminate the record for that particular class only. No change in the class till now. I've considered one class, I'm still in that particular class only. I have to derive rules until I find, until I'm not able to find a particular desired rule, then till then I will keep on repeating. I'll identify the rule, eliminate the record. Identify the rule, eliminate the record. So once I found that no desirable rule is possible for the given class, now I will change the class. I will change the class and then repeat the same thing from the beginning for that particular second class. for that particular second class. Okay, so this is how the learn one rule function works. So let us see. I'll explain same thing with respect to one example. Okay, so consider that I'm having a training set. So let this be the training set that I'm having. This here I have considered all as negatives. This is not a dash here. Consider this as a negative sign. So why I have considered it as negative means here I have records which belongs to multiple classes. Okay, so from this, say consider I'll identify one class and make it as positive, and all records that belong to that particular class is positive. These are also refers to the records present. Okay, this negative sign here also refers to the records. It refers to the records which belongs to different class. Now out of these I will take one class and identify all the records that belong to that particular class and make it positive like this. So which means, so these records here, this 6 record here, these 4 records here, and these 4 records here belongs to one class. Say let it be birds only. So these are the records that are present in the data set, training set, which belongs to various different classes. Now I have considered one class and I am going to identify all records that belonging to that particular class, and I'm going to make it positive. So this is what it is, second box. Okay, so here I can see that these plus indicates that these are the records which belongs to one class. Say the class is bird. Now what I do is I try to find a rule which covers maximum of the positive class. So here I have a few records here, I have few records here, I have few records here. So which set of records to consider first? Because as I told, we are going to extract the decision list, which means I have to derive the rules in any particular order. So what is the order I'm going to consider here? So that also becomes very important. Correct. So what I do is, in this case, I'm going to consider I'm going to take which that particular cluster. Say I call it as cluster. Cluster means group of particular item, right? So I say consider this cluster I'm going to consider, which is having 6 records, which means if I derive a rule here for this particular cluster, it is going to cover 6 records, whereas these two are going to cover only 4 records. So this is going to cover more number of records. I will derive a rule for this. So I'm going to consider that and derive a rule for it. So now I have derived a rule. That is why I have covered it. Which means I have derived a rule. Now what I have to do is I have to consider the next thing, correct? Now I have to consider next among this. So for this I have considered rule 1. Right? Rule 1 will be done. So what I'm going to do, I'm going to eliminate this. Why I have covered this? Because I have identified a rule. I will name it as rule 1. Okay, rule 1. Now you can see this positive. These records are eliminated. Here I don't have a record. I've just written it as R1 because I have identified a rule and I have removed these records. Understood, correct? Now what I'm going to do is I'm going out among these two, which is going to cover 4 records each, I have to derive a rule. Now whether I have to consider this cluster or I have to consider this cluster, because I want the rules to be derived in a particular way, right? Particular fashion. So for that, what I do is I try to cover this cluster. I'll cover it. So I can find that I have one negative rule being covered. If a rule is derived for this, there's one negative rule that is covered. So we know that when I derive a rule in the learn one rule function, I should derive the rule in such a way that it will not cover a negative rule, or even if covered, it should have a minimum. Okay, so here in this case, I have one negative rule. So what I do is, I will check with this also, whether this is possible to derive, whether here is it possible to derive a rule without covering a negative record. So I try to cover this. So I found when I tried to cover this, I found that there are 2 negative examples getting covered here. Now decide among these two which will be the best one according to our the conditions led by our learn one rule function, this is the best one, right? Because it is having only one negative rule being covered. Here there are two negative rules covered. So what I do is, first I derive rule for this. First I derive rule for this. Understood? So what I did, you have understood, right? So I had a confusion regarding deriving rules for this or this first, because whether I derive rule for this or this, it is going to anyways cover 4 records only, both of these. So for that, I'll make use of that condition led by the learn one rule. What is that condition? When I derive a rule, it should cover maximum of positive class and minimum of negative class. So I tried to cover this with one rule. I found that one negative class is getting covered. Here I tried to cover this particular records, but I found that there are two negative class getting covered. Therefore, what I do is, among this, the best one will be deriving rule first for this and then for this. So I'm going to cover this in the as a rule 2. So now I'll proceed. What I have to do, I have to eliminate this. So I eliminated and I have marked it as rule 2. Understood, right? Till here, how I derive for the R2. Now I'm left with only this, because I'm not yet completed with all the positive examples. We have once all how much ever positive examples is identified, you have to derive rules for that first and then go for the next class. Remember that. So here I still have some of the positive rule, so I don't have any other option. I have to cover it, whether it is having negative rules or not. I have to cover it. I tried my best to reduce the coverage of negative rules, but I was able to reduce it up to only maximum of 2 negative rules. So now what I do is, I take this as rule 3 and eliminate all these records. So now for the class birds, I have 3 rules being derived. So these 3 rules will be listed in the order R1, R2, R3 in the R1, R2, R3 in the decision list. So this will be listed as R1, R2, R3 in the decision list. Okay. So for the first class which we have considered, we have derived 3 rules. Now, so one iteration of one iteration of learn one rule function is done with respect to one particular class. Now what I have to do is, among these negatives present here, identify the class which belongs to, identify the records which belongs to same class, and repeat from here again. Same thing will be repeated. Okay. So the hope you have understood this learn one function very well with this particular example, right? Okay, so now what we have done is, we have for the class 1, we have derived 3 rules. Next, consider class 2, consider it, let it be amphibians. Okay, for amphibians, make those records which belongs to amphibians as positive and follow the procedure. Okay, so this is about your learn one rule function, how it works with respect to sequential covering. So this is also your sequential coverage. Thank you, students. If you have any doubts or queries or for feedback, you can write back to me. Thank you.